1995, a Japanese expedition diving off Yonaguni Island discovered something that should have rewritten history. Massive stone structures with perfect right angles, carved steps, and geometric precision submerged 12,000 years ago when sea levels rose after the last ice age. But instead of celebration, there was silence. The discovery was quietly classified as natural rock formations, despite overwhelming evidence to the contrary. This wasn't an isolated incident. Across 6 continents, identical architectural impossibilities are being discovered, suppressed, and explained away. The precision stone cutting, the astronomical alignments, the mathematical principles that primitive cultures couldn't have known. When you connect the dots, a terrifying pattern emerges. Someone taught the world to build, then every trace of their existence was systematically erased. The morning light filtered through the dust motes dancing above Professor Sarah Chen's desk as she stared at the satellite images spread before her. Each photograph told the same impossible story. Ancient structures appearing simultaneously across the globe within a window of time so narrow it defied every accepted theory of human development. Her hands trembled slightly as she reached for the magnifying glass, knowing that what she was about to document would challenge everything mainstream archaeology had taught the world to believe. Chen had spent 15 years studying megalithic construction across 4 continents, and the pattern that emerged haunted her dreams. Sometime around 10,500 BC, scattered groups of hunter-gatherers, people who supposedly lived in crude shelters and possessed only the most basic tools, suddenly began constructing monuments that modern engineers struggle to replicate. The transition wasn't gradual. It wasn't regional. It happened everywhere, all at once, as if someone had flipped a switch across the entire planet. The official explanation had always been convergent evolution, the idea that similar challenges naturally produce similar solutions, even among isolated cultures. But Chen's research revealed something far stranger. These weren't merely similar solutions. They were identical techniques, shared down to the smallest detail, appearing simultaneously across vast oceans among people who supposedly had never met. Take the precision stone cutting found at Pumapunku in Bolivia. The H-blocks there are carved with tolerances measured in fractions of millimeters, their surfaces so perfectly smooth they seem to flow together like liquid. The joints are so tight that not even a razor blade can slip between the stones. According to conventional archaeology, the people who built this site possessed only copper and stone tools, yet they achieved precision that would challenge modern machinery. Now examine the megalithic walls at Sacsayhuaman in Peru. The same impossible precision, the same flowing joints, the same technique of cutting massive stones into interlocking polygonal shapes that create earthquake-resistant structures. The official timeline places these constructions around 1500 AD, built by the Inca using bronze tools and human labor. Yet the precision rivals anything found in Bolivia, constructed using identical methods by a completely different culture separated by hundreds of miles and supposedly thousands of years. But the pattern doesn't stop in South America. Travel to Lebanon, to the ancient site of Baalbek, and you'll find the same polygonal masonry technique used in the foundation stones. These aren't just large blocks. They're the heaviest worked stones ever quarried by human beings. The largest, known as the Stone of the Pregnant Woman, weighs over 1,000 tons. Moving such a mass would challenge modern engineering, yet according to mainstream chronology, it was quarried and positioned by people using only primitive tools and manual labor. The technique appears again in the underwater structures off Japan's coast. The same precise cutting, the same interlocking blocks, the same mathematical precision that create structures capable of withstanding enormous pressure and geological stress. Yet these monuments were submerged when the last ice age ended, placing their construction in a period when humans supposedly possessed no knowledge of sophisticated building techniques. Easter Island presents perhaps the most puzzling example. The famous Moai statues capture attention, but the precision-cut stone platforms they stand upon tell a different story. The Ahu platforms demonstrate the same megalithic construction techniques found across the Pacific and around the world. Massive stones fitted together with impossible precision, created by a supposedly isolated culture that had no contact with the outside world for centuries. Chen pulled out her field notes from Göbekli Tepe in Turkey. Here, the pattern took on an even more unsettling dimension. The site predates Stonehenge by 6,000 years and was built by people who supposedly hadn't yet developed agriculture. Yet the stone pillars are carved with sophisticated reliefs and arranged in complex geometric patterns that demonstrate an advanced understanding of engineering principles. The site required coordinated effort by hundreds of workers over decades, yet it was constructed by hunter-gatherers who supposedly lived in small, nomadic groups. What made Göbekli Tepe particularly disturbing was its deliberate burial. Around 8000 BC, the entire complex was carefully covered with tons of earth and rock. Someone had gone to enormous effort to hide this monument from future generations. Why would people who had invested decades in creating such a masterpiece suddenly decide to bury it forever? The pattern extended beyond construction techniques to knowledge that shouldn't have existed. The Great Pyramid of Giza encodes mathematical constants that weren't discovered until centuries later. Its base perimeter divided by its height yields pi. Its proportions embody the golden ratio. The structure is aligned to true north with an accuracy of 3/60ths of a degree, more precise than most modern buildings. Ancient Mayan structures demonstrate similar impossible knowledge. The pyramid at Chichen Itza creates acoustic effects that replicate the call of a quetzal bird when you clap at its base. The Temple of Kukulkan is positioned so that during the equinoxes, shadows create the illusion of a serpent descending its steps. These aren't accidents. They're evidence of a sophisticated understanding of acoustics, astronomy, and human psychology. The Antikythera mechanism, pulled from a Greek shipwreck in 1901, revealed that ancient civilizations possessed mechanical computing devices that could predict eclipse cycles and planetary positions with startling accuracy. The device was so sophisticated that similar complexity didn't reappear until mechanical clocks were developed in the 14th century AD. But perhaps the most troubling aspect of Chen's research wasn't what these ancient cultures knew. It was how quickly that knowledge disappeared. The precision construction techniques that appeared simultaneously around the globe began degrading within centuries. Later structures showed increasing crudeness, as if the builders were working from incomplete instructions or fading memories of techniques they no longer fully understood. The Egyptian pyramids provide a perfect example. The earliest pyramids demonstrate the highest level of precision and engineering sophistication. Later pyramids show declining quality, as if each generation possessed less knowledge than the one before. By the time of the New Kingdom, Egyptian construction techniques had devolved to stacking stones with mortar, a dramatic decline from the precision fitting of the Great Pyramid. This pattern of knowledge loss appeared worldwide. The precise stone cutting at Pumapunku was never replicated in later Bolivian construction. The acoustic engineering of Mayan temples disappeared from subsequent buildings. The mechanical complexity of the Antikythera mechanism wasn't matched by any other Greek device. Everywhere, the earliest examples showed the highest sophistication, followed by gradual degradation over time. Chen's research suggested a disturbing possibility. These ancient cultures weren't developing their knowledge through trial and error. They were copying techniques they didn't fully understand, working from instructions or examples provided by teachers who had since vanished. As those original sources were lost or corrupted, the quality of construction inevitably declined. The implications struck at the heart of everything she'd been taught about human development. If advanced knowledge appeared simultaneously across isolated cultures, then someone must have been teaching them. But who possessed such a sophisticated understanding 12,000 years ago? And what happened to these mysterious instructors? The questions multiplied as Chen examined the evidence. Why did the most advanced construction techniques appear earliest in the archaeological record, contradicting everything known about technological development? Why did similar techniques emerge simultaneously among cultures separated by vast distances and natural barriers? And why did this knowledge disappear so quickly, as if its source had been suddenly cut off? Most troubling of all was the pattern of deliberate concealment that appeared throughout the archaeological record. Göbekli Tepe wasn't the only site that had been intentionally buried. Across the globe, evidence suggested that knowledge was being systematically hidden or destroyed. Someone didn't want future generations to discover what these ancient cultures had known. As Chen prepared to publish her findings, she began to understand why so many of her colleagues avoided making these connections. The evidence pointed toward conclusions that challenged fundamental assumptions about human history. If ancient cultures possessed knowledge they couldn't have developed independently, then the story of human civilization needed to be completely rewritten. But rewriting history meant confronting powerful institutions whose authority rested on maintaining current narratives. It meant questioning the expertise of generations of scholars who had built their careers on theories that might be fundamentally flawed. Most disturbing of all, it suggested that modern civilization might not represent the pinnacle of human achievement, but rather a slow recovery from catastrophic loss of knowledge. The morning sun had climbed higher as Chen worked, casting new shadows across the photographs spread before her. Each image seemed to whisper the same question. If these impossible achievements were real, and if the pattern of simultaneous emergence was undeniable, then what force could create such precision across such vast distances in such a compressed timeframe? The answer to Chen's question lay buried in the mountains of Peru, where master stonemason Roger Hopkins faced the challenge of his career. Standing before the megalithic walls of Sacsayhuaman in 2002, Hopkins had been commissioned by Nova to demonstrate how the Inca could have achieved their legendary precision using only bronze tools and human labor. He possessed decades of experience, modern measuring instruments, and complete freedom to experiment with techniques. What happened next would shatter every assumption about ancient construction methods. Hopkins selected a relatively small stone, a mere 4-ton block of andesite, the same volcanic rock used in the original walls. His team of Peruvian stonemasons, descendants of the original builders, attacked the stone with bronze chisels and hammers, employing every technique passed down through generations. They worked for days under the scorching Andean sun, their hands bleeding from the constant impact against unyielding rock. After a week of backbreaking labor, they had managed to rough out basic shapes, but the surfaces remained crude and uneven. The joints gaped with spaces large enough to insert fingers. The precision that characterized the ancient walls, tolerances measured in fractions of millimeters, remained impossibly beyond their reach. Hopkins' experiment had proven only one thing: The methods attributed to the original builders couldn't possibly have created the monuments that surrounded them. The failure wasn't unique to Hopkins' team. Across the globe, attempts to replicate ancient precision using proposed historical methods have consistently ended in defeat. In Lebanon, modern engineers using pneumatic tools and laser-guided equipment struggle to match the tolerances achieved at Baalbek. In Egypt, attempts to recreate pyramid construction techniques using ramps and copper tools have produced structures that bear little resemblance to the original's mathematical perfection. What makes this failure so disturbing isn't just the gap between ancient achievement and modern attempts, it's the specific nature of that precision itself. These aren't randomly accurate constructions. They demonstrate a systematic understanding of principles that wouldn't be codified for thousands of years. Consider the mathematical relationships embedded in the Great Pyramid. The structure's height multiplied by 1 billion approximates the distance from Earth to the Sun. Its base perimeter divided by twice its height yields pi to 15 decimal places. The pyramid's internal chambers align with stellar positions that wouldn't be visible again for 26,000 years. These aren't coincidences. They're evidence of deliberate encoding of advanced mathematical and astronomical knowledge. But the precision paradox extends beyond mathematics into the realm of materials science. Analysis of ancient bronze artifacts reveals metallurgical sophistication that challenges everything known about technological development. Bronze tools found in Egyptian tombs contain trace elements that improve hardness and durability in ways that weren't understood until the 20th century. The specific ratios of copper, tin, and additional metals follow formulas that modern metallurgists recognize as optimal. Yet these compositions appear in artifacts predating the theoretical development of such knowledge by millennia. The stone cutting itself reveals even stranger anomalies. Microscopic analysis of surfaces at Puma Punku shows tool marks that don't match any known cutting implement. The grooves are too uniform, too precisely spaced, and demonstrate cutting speeds that would be impossible to achieve with bronze or copper tools. Some researchers have noted that the marks resemble those created by high-speed diamond-tipped cutting wheels, technology that didn't exist until the industrial age. Dr. Christopher Dunn, a machinist with 40 years of experience in precision manufacturing, examined similar anomalies in Egyptian granite work. His analysis of the sarcophagus in the king's chamber revealed evidence of machine tooling that surpassed anything achievable with hand tools. The internal corners showed radii that could only be created by rotating cutting tools. The surface finish indicated feed rates and cutting speeds consistent with modern machinery. When Dunn attempted to replicate the work using the tools supposedly available to ancient Egyptians, the results were laughably crude compared to the originals. Copper chisels dulled within minutes against granite. Bronze tools, even when work hardened, couldn't maintain the sharp edges necessary for precision cutting. Sand and copper tube drilling, the method proposed by mainstream archaeology, produced rough, irregular holes that bore no resemblance to the perfectly circular, precisely dimensioned bores found in ancient work. The paradox deepens when examining the logistics of ancient construction. Moving the largest stones at Baalbek would require coordinated effort by thousands of workers using techniques that remain unclear even today. The trilithon stones, each weighing over 800 tons, were quarried, transported, and positioned with millimeter precision. Modern cranes capable of lifting such weights didn't exist until the late 20th century. Yet these stones were moved and placed with an accuracy that suggests understanding of engineering principles far beyond what conventional timelines allow. Easter Island presents perhaps the most puzzling logistical challenge. The Moai statues were carved at a central quarry, then somehow transported across the island to their final positions. The largest transported statue weighs 82 tons and was moved over 11 miles of rough terrain. Recent experiments using rope teams and wooden rollers have succeeded in moving small replicas short distances, but scaling these methods to handle the largest statues across the island's challenging landscape remains theoretical at best. What makes the transportation mystery more complex is evidence that many statues were moved intact with their massive headdresses, called hukao, already in place. These red scoria crowns weigh up to 12 tons each and were somehow lifted and positioned atop statues that already stood 30 feet tall. The logistics of such an operation would challenge modern construction equipment, yet it was supposedly accomplished by a culture that had exhausted its island's tree resources and possessed no large domestic animals. The precision paradox isn't limited to massive construction projects. Smaller artifacts demonstrate the same impossible accuracy achieved through unknown methods. The Antikythera mechanism contains gear ratios calculated to predict astronomical cycles with precision that wasn't matched until the development of modern planetary theory. The device's bronze gears were cut with tolerances measured in fractions of millimeters, requiring manufacturing techniques that supposedly didn't exist for another 1,000 years. Chinese bronze vessels from the Shang dynasty demonstrate casting precision that modern foundries struggle to replicate. The ritual vessels show perfect wall thickness throughout complex shapes, indicating temperature control and metal flow understanding that wouldn't be codified until the Industrial Revolution. Some vessels contain internal structures that would be impossible to create using the sand casting methods attributed to ancient Chinese metallurgists. The precision extends to less obvious but equally challenging aspects of construction. Acoustic engineering at ancient sites demonstrates understanding of sound propagation and resonance that wasn't formalized until the development of modern physics. The whispering galleries at sites like Giza and Chichen Itza show deliberate manipulation of architectural forms to create specific acoustic effects. These aren't accidents. They require a precise understanding of how sound waves interact with three-dimensional spaces. Thermal engineering appears in unexpected contexts as well. The hypocaust systems found in Roman ruins demonstrate a sophisticated understanding of heat transfer and fluid dynamics. But similar principles appear in much earlier constructions, including underground chambers at Derinkuyu in Turkey that maintain stable temperatures year-round through passive thermal design. The mathematical calculations required to achieve such climate control weren't developed until the modern era, yet the engineering results speak for themselves. Perhaps most puzzling are the instances where ancient precision exceeds modern capabilities. The Damascus steel produced in medieval Syria demonstrates metallurgical properties that modern science can explain but not fully replicate. The steel's distinctive patterns result from carbon nanotube formation that creates strength and flexibility combinations unmatched by contemporary materials. Recent attempts to recreate true Damascus steel have achieved visual similarity but fall short of the mechanical properties that made the original legendary. Similar examples appear across multiple cultures and time periods. Japanese swordsmiths created blades with hardness gradients that require precise temperature control throughout the forging process. The mathematical relationships governing heat distribution in complex shapes weren't understood until computer modeling became available, yet the results demonstrate mastery of principles that theory couldn't explain. The precision paradox forces a troubling conclusion. Either conventional timelines for technological development are completely wrong, or ancient cultures possess knowledge from sources that mainstream history refuses to acknowledge. The evidence suggests that a sophisticated understanding of mathematics, engineering, metallurgy, and physics appeared fully formed in the archaeological record, rather than developing gradually through trial and error. This sudden appearance of advanced knowledge mirrors the pattern Chen had identified in construction techniques. Sophisticated capabilities emerging simultaneously across isolated cultures, followed by gradual degradation over time. The most precise work appears earliest in the archaeological record, with later examples showing declining accuracy as if working from incomplete instructions or corrupted knowledge. The implications challenge fundamental assumptions about human intellectual development. If ancient cultures possessed advanced technical knowledge, where did that knowledge originate? How was it transmitted across vast distances to isolated populations? And why did such sophisticated understanding disappear, leaving later civilizations to rediscover principles that had once been mastered? The precision achieved by ancient builders wasn't just impressive for its time, it remains impressive by today's standards. Modern attempts to replicate their work consistently fall short, despite access to advanced tools, computer modeling, and centuries of accumulated engineering knowledge. This suggests that whatever methods the ancients employed were fundamentally different from anything in the contemporary technological toolkit. As researchers continue to analyze ancient achievements with increasingly sophisticated instruments, the precision paradox only deepens. Each new measurement reveals additional layers of sophistication that shouldn't exist according to conventional timelines. The more precisely scientists can measure ancient work, the more impossible it becomes to explain using accepted theories of technological development. The morning sun cast sharp shadows across the Sacsayhuaman walls as Hopkins packed his tools, defeated by stones that had yielded their secrets to builders millennia before his birth. The perfect joints mocked his efforts, their precision a testament to knowledge that seemed to have emerged from nowhere and vanished just as mysteriously. What manner of instruction could produce such perfection among people who supposedly possessed only the crudest implements? The discovery that would change everything arrived in a manila envelope slipped under Dr. Marcus Webb's office door on a rain-soaked Tuesday morning in London. Inside, satellite photographs revealed something that shouldn't exist: identical stone-cutting patterns at sites separated by 8,000 miles of ocean. The images showed Sacsayhuaman in Peru, alongside the underwater ruins off Yonaguni Island in Japan. The construction techniques were not merely similar, they were identical down to the specific angle of cut, the interlocking joint design, and the mathematical proportions governing stone placement. Webb had spent 2 decades studying megalithic construction across the Mediterranean, but these photographs forced him to confront a possibility that challenged everything he thought he knew about ancient cultures. The envelope contained no return address, no explanation, just dozens of comparison images that revealed a pattern so systematic it could only represent coordinated instruction across the ancient world. The first image pair showed the polygonal masonry technique that Webb knew from his work at ancient Greek sites. Massive stones cut into irregular shapes that fitted together like 3-dimensional puzzles, creating joints so tight that not even a knife blade could penetrate between them. But the second photograph showed identical construction at Machu Picchu, built by people who supposedly had never encountered Mediterranean building methods. The third comparison revealed the same technique at a site Webb had never heard of, the underwater structures off the coast of Bimini in the Bahamas. The stones showed the same precise cutting, the same interlocking design, the same mathematical relationships governing their arrangement. Yet these ruins were submerged when sea levels rose at the end of the last ice age, placing their construction thousands of years before conventional timelines suggested such sophisticated building methods existed anywhere in the world. As Webb studied image after image, a disturbing pattern emerged. The identical techniques weren't limited to stone cutting. The photographs revealed shared architectural principles that spanned continents and millennia. Acoustic chambers designed to amplify sound in specific ways appeared at sites in Malta, Mexico, and Easter Island. Astronomical alignments following identical mathematical formulas governed structures from Stonehenge to Angkor Wat to the Nazca Lines. The evidence suggested something that mainstream archaeology refused to consider. These weren't independent developments by isolated cultures. They were lessons taught by instructors who possessed advanced knowledge and traveled across the ancient world, sharing their expertise with local populations. Webb pulled out his own research files and began cross-referencing the anonymous photographs with his decades of fieldwork. The connections multiplied beyond any possibility of coincidence. The specific ratio used in Greek temple proportions, 1.618, the golden ratio, appeared in pyramid construction in Egypt, temple design in Cambodia, and stone circle arrangements in Britain. This wasn't cultural diffusion through trade routes. These sites predated any known contact between their respective civilizations. The mathematical relationships governing ancient construction revealed even deeper layers of shared instruction. The number 26 appeared repeatedly in site measurements across the globe. 26 stones in certain circles. Dimensions that were multiples of 26. Alignments that corresponded to the 26,000-year precession cycle of Earth's axis. Ancient builders from cultures that supposedly possessed no astronomical knowledge were encoding the same cosmic cycle into their monuments. Sacred geometry provided another thread connecting distant civilizations. The Vesica Piscis, the almond-shaped intersection of two circles, appeared carved in stone at sites from Ireland to India. The flower of life pattern created by overlapping circles in precise mathematical relationships decorated temples in Egypt, China, and Mexico, built by cultures that had no known contact with each other. These weren't simple decorative motifs. They were sophisticated geometric constructions that required advanced mathematical understanding. The construction techniques themselves revealed systematic instruction that transcended cultural boundaries. The method of creating earthquake-resistant walls by cutting stones into interlocking polygonal shapes appeared simultaneously in Peru, Greece, and Japan, three regions prone to seismic activity but separated by vast distances and natural barriers. The technique wasn't intuitive. It required an understanding of stress distribution and material properties that wouldn't be formalized until modern engineering developed. Acoustic engineering provided perhaps the most compelling evidence of shared instruction. The whispering galleries at ancient sites demonstrated an identical understanding of sound propagation principles. A whisper at one end of the gallery at Giza could be heard clearly at the other end, 90 feet away. The same acoustic property appeared in galleries at sites in Malta, Mexico, and Peru, built by cultures that supposedly developed independently. The precision required to create such acoustic effects isn't accidental. It requires mathematical calculations governing the relationship between space dimensions, surface materials, and sound wavelengths. Modern architects use computer modeling to achieve similar results, yet ancient builders accomplished identical effects using principles they supposedly couldn't have known. Water management systems revealed another layer of shared knowledge. Advanced hydraulic engineering appeared simultaneously across ancient civilizations, demonstrating understanding of fluid dynamics, pressure differentials, and flow control that wouldn't be systematized until the Renaissance. The underground aqueducts of Nazca employed the same principles as the water systems at Petra and the hydraulic networks beneath Angkor Wat, These weren't simple irrigation channels. The ancient systems demonstrated a sophisticated understanding of water table dynamics, seasonal flow variations, and pressure regulation. The Nazca Puquios, underground channels that still provide water to modern communities, employ engineering principles that require a precise understanding of subsurface hydrology. Similar systems appeared independently in cultures that had no apparent connection to each other. Metallurgical knowledge provided yet another thread of evidence. Bronze alloys with identical compositions appeared simultaneously in cultures separated by vast distances. The specific ratios of copper, tin, and trace elements that created optimal hardness and durability were discovered independently by civilizations that supposedly had no contact with each other. But the compositions weren't random discoveries. They followed mathematical relationships that suggested systematic instruction in metallurgical principles. The lost wax casting technique, used to create complex bronze sculptures, appeared simultaneously in ancient China, Greece, and Peru. The process requires a precise understanding of metal flow dynamics, thermal expansion rates, and cooling patterns that affect the final product's quality. Modern foundries use computer modeling to optimize these variables, yet ancient metalworkers achieved identical results using knowledge they supposedly developed through trial and error. Webb's analysis revealed that the shared techniques weren't limited to massive construction projects. Smaller artifacts demonstrated the same systematic instruction across cultures. Precision bronze mirrors with mathematical curves that focused light into parallel beams appeared in China, Egypt, and Peru. The mathematical relationships governing these curves wouldn't be understood until the development of modern optics. Yet ancient craftsmen created mirrors that demonstrated mastery of principles that theory couldn't yet explain. Surgical instruments found in ancient tombs showed identical designs across cultures separated by continents and centuries. Trepanation tools, instruments used for brain surgery, followed the same engineering principles in Peru, Egypt, and ancient Europe. The specific angles and cutting edges weren't intuitive designs. They reflected an understanding of cranial anatomy and surgical technique that required systematic instruction in medical procedures. Navigation instruments provided another layer of evidence. Ancient mariners possessed tools that demonstrated an understanding of celestial mechanics, magnetic declination, and spherical geometry that enabled transoceanic voyages thousands of years before such knowledge was supposedly developed. The Antikythera mechanism represented only the most complex example of a widespread tradition of precision instrument making that appeared across multiple cultures. The evidence forced Webb to confront an unsettling conclusion. Ancient civilizations had access to a curriculum of advanced knowledge that was taught systematically across the globe. The techniques weren't developed independently through gradual experimentation. They appeared fully formed, as if transmitted by instructors who possessed a sophisticated understanding of engineering, mathematics, astronomy, and physics. But who were these instructors? How did they travel across vast distances to teach isolated cultures? And why did their systematic instruction leave such consistent evidence while the teachers themselves vanished from the historical record? The pattern suggested a coordinated educational effort that spanned the ancient world. Master builders, mathematicians, astronomers, and engineers had somehow reached every continent, sharing their knowledge with local populations who then incorporated these advanced techniques into their own construction projects. The instruction wasn't random or haphazard. It followed a consistent curriculum that emphasized specific principles and techniques. The degradation of knowledge over time provided additional evidence of systematic instruction. The earliest examples of ancient construction showed the highest level of sophistication, with later works demonstrating declining precision as if built by students working from incomplete notes after their teachers had departed. This pattern appeared worldwide, suggesting that the source of advanced knowledge had been suddenly removed. Archaeological evidence supported the theory of systematic instruction through the discovery of what appeared to be teaching materials. Stone tablets with geometric diagrams, astronomical calculations, and engineering principles had been found at sites across the globe. These weren't religious texts or administrative records. They were technical manuals that demonstrated how advanced knowledge was transmitted to local populations. The manuals showed step-by-step instructions for techniques that appeared in construction projects worldwide. Geometric relationships for creating stable foundations, astronomical calculations for aligning structures with celestial bodies, and mathematical formulas for achieving specific acoustic properties. The instructions were detailed enough to enable local populations to replicate sophisticated techniques, but they assumed underlying knowledge that the students apparently didn't fully possess. As Webb compiled his evidence, the scope of the ancient educational effort became clear. This wasn't cultural diffusion through trade or conquest. It was systematic instruction by teachers who possessed advanced knowledge and deliberately shared it with cultures across the globe. The consistency of techniques, the mathematical relationships, and the sophisticated understanding of natural principles all pointed to coordinated educational effort by instructors whose identity remained mysterious. The implications challenged everything mainstream archaeology taught about ancient civilizations. If such systematic instruction had occurred, then human development would have followed a completely different pattern than conventional theories suggested. Advanced knowledge hadn't developed gradually through trial and error. It had been transmitted to ancient cultures by teachers whose own origins remained unknown. The rain continued to streak down Webb's office windows as he studied the final photograph in the envelope. It showed a construction detail from a newly discovered site in Turkey, where archaeologists had uncovered evidence of the same systematic instruction that appeared worldwide. The precision cutting, the mathematical proportions, the sophisticated engineering, all the hallmarks of the global classroom that had somehow operated across the ancient world. Who had possessed such advanced knowledge 12,000 years ago, and what had happened to these mysterious teachers whose lessons could still be read in stone monuments across every continent? The numbers began appearing to Dr. Elena Vasquez in her dreams, pi to 15 decimal places carved into pyramid stones. The golden ratio is hidden in temple proportions. Euler's number is encoded in astronomical alignments that predate its mathematical discovery by 3,000 years. As Cambridge's leading archaeoastronomer, Vasquez had spent her career analyzing the mathematical relationships embedded in ancient monuments. But the pattern that emerged from her latest research suggested something far more disturbing than sophisticated geometry. It revealed evidence of advanced mathematical knowledge that shouldn't have existed for millennia. The breakthrough came while analyzing laser measurements from the Great Pyramid of Giza. The structure's dimensions encoded mathematical constants with precision that defied explanation. The pyramid's height, multiplied by 1 billion, approximated the distance from Earth to the Sun, 93 million miles, accurate to within 1%. Its base perimeter divided by twice its height yielded pi to 15 decimal places. The internal passage angles corresponded to the golden ratio, while the chamber proportions embodied mathematical relationships that wouldn't be formally recognized until the Renaissance. But Giza wasn't unique. As Vasquez expanded her analysis to other ancient sites, identical mathematical constants appeared with disturbing consistency. The golden ratio, 1.618, governed proportions at Stonehenge, Angkor Wat, and Machu Picchu. The number E, Euler's constant at 2.718, appeared in the mathematical relationships controlling spiral designs at sites from Ireland to Easter Island. These constants weren't approximate or coincidental. They were precise to multiple decimal places, embedded in structures built by cultures that supposedly hadn't developed the mathematical frameworks necessary to understand such concepts. The pattern extended beyond individual constants to encompass entire mathematical systems. Ancient monuments demonstrated understanding of trigonometry, calculus, and astronomical mechanics that wouldn't be formalized for thousands of years. The pyramid complexes at Teotihuacan encoded the mathematical relationships governing planetary orbits with precision that wasn't achieved by European astronomers until the development of Kepler's laws in the 17th century. Stonehenge presented perhaps the most complex mathematical puzzle. The monument's stone circles incorporated 56 Aubrey holes, arranged in precise mathematical relationships that enabled the prediction of lunar eclipses decades in advance. The calculations required an understanding of the 18.6-year lunar cycle, the 19-year Metonic cycle, and the complex interactions between solar and lunar calendars. Modern astronomers use computer models to make similar predictions. Yet Neolithic builders encoded these calculations in stone monuments using mathematical principles they supposedly couldn't have comprehended. The Antikythera mechanism revealed the full extent of ancient mathematical sophistication. The device's bronze gear ratios were calculated to predict astronomical cycles with precision that required understanding of planetary mechanics, differential equations, and complex gear train mathematics. The mechanism's design incorporated knowledge that wouldn't be rediscovered until the development of mechanical clockwork in medieval Europe. Yet it was constructed using mathematical principles that exceeded anything achieved by classical Greek mathematicians. Vasquez's analysis revealed that the mathematical knowledge wasn't limited to astronomy and engineering. Ancient cultures demonstrated an understanding of advanced geometric principles that enabled them to solve problems that challenged mathematicians for centuries. The duplication of the cube, one of the classical problems that stumped Greek geometers, was solved practically by pyramid builders who incorporated the solution into their monument proportions without leaving any theoretical explanation of their methods. The quadrature of the circle, the impossible task of constructing a square with the same area as a given circle, appeared to have been solved by multiple ancient cultures. Stone circles in Britain, temple foundations in Cambodia, and ceremonial platforms in Peru all demonstrated practical applications of mathematical relationships that enabled approximate solutions to this classical problem. The builders achieved these results without developing the theoretical mathematics that would prove such constructions impossible using classical geometric methods. Number theory provided another layer of mathematical sophistication that shouldn't have existed in ancient cultures. Prime number sequences appeared in monument alignments across multiple civilizations. The Fibonacci sequence, where each number equals the sum of the two preceding numbers, governed spiral designs in everything from Nautilus shell carvings to temple floor plans to astronomical calendar calculations. These mathematical relationships weren't decorative choices. They were systematic applications of number theory that required an understanding of mathematical principles that wouldn't be formalized until the Middle Ages. The mathematical constants appeared with such consistency across ancient cultures that Vasquez began to suspect systematic instruction. The same ratios, the same geometric relationships, the same astronomical calculations appeared at sites built by civilizations that supposedly had no contact with each other. Either mathematical knowledge had developed independently dozens of times across isolated cultures, or someone had been teaching these principles systematically across the ancient world. The evidence for systematic mathematical instruction appeared in unexpected places. Babylonian tablets contained mathematical tables that enabled complex astronomical calculations with precision that wasn't matched until the development of modern computational methods. The tables included square roots calculated to 6 decimal places, trigonometric functions accurate enough for navigation, and logarithmic relationships that facilitated multiplication of large numbers. These weren't theoretical exercises. They were practical tools that enabled advanced engineering and astronomical work. Egyptian mathematical papyri revealed similar sophistication. The Rind papyrus contained methods for calculating pyramid volumes, sphere areas, and truncated pyramid volumes using mathematical techniques that demonstrated understanding of geometric principles far beyond basic arithmetic. The calculations employed algebraic methods that wouldn't be formalized until the Islamic Golden Age, yet they appeared in practical applications that enabled the engineering marvels of pyramid construction. Chinese mathematical texts from the Han Dynasty contained solutions to problems in linear algebra, geometric series, and differential approximation that paralleled developments in Indian and Islamic mathematics centuries later. The Chinese had developed methods for solving systems of linear equations, calculating square roots through iterative approximation, and determining areas under curves using techniques that anticipated integral calculus. These mathematical tools enabled engineering projects like the Great Wall and advanced astronomical observations that tracked planetary motions with remarkable precision. Mayan mathematical achievements surpassed those of their Old World contemporaries in several areas. The Maya developed positional notation, including 0 as a placeholder, a concept that didn't appear in European mathematics until it was borrowed from Indian sources in the medieval period. Mayan astronomical calculations tracked Venus cycles, eclipse predictions, and calendrical correlations with precision that required mathematical techniques equivalent to modern computational astronomy. But perhaps most disturbing was the evidence that ancient cultures possessed mathematical knowledge that exceeded what their practical applications required. The precision of astronomical calculations far surpassed what was necessary for agricultural calendars or religious ceremonies. The mathematical constants embedded in monuments were accurate to more decimal places than could be measured using ancient instruments. The geometric relationships were more sophisticated than required for structural stability or aesthetic proportion. This suggested that ancient mathematical knowledge wasn't developed for practical purposes. It was a theoretical understanding that was then applied to practical problems. The builders possessed advanced mathematical frameworks that they used selectively in their construction projects, encoding knowledge that far exceeded the apparent needs of their civilizations. The degradation pattern that appeared in construction techniques also affected mathematical knowledge. The earliest monuments demonstrated the highest level of mathematical sophistication, with later structures showing declining precision, as if built by people working from incomplete mathematical instructions. Egyptian pyramids provide a clear example. The mathematical relationships in the Great Pyramid surpass those in later pyramids, suggesting that the original mathematical knowledge was gradually lost over successive generations. Similar degradation appeared worldwide. Early Mayan astronomical texts contained more sophisticated mathematics than later codices. Chinese mathematical techniques from the Han period exceeded those developed during subsequent dynasties. Greek mathematical knowledge appeared to decline after the classical period, with later mathematicians struggling to understand theorems that earlier scholars had taken for granted. The pattern suggested that advanced mathematical knowledge had been transmitted to ancient cultures by teachers who possessed an understanding that exceeded anything developed through indigenous mathematical traditions. The knowledge appeared fully formed rather than developing gradually through mathematical research and discovery. When the original source was lost, mathematical understanding inevitably declined as students worked from incomplete notes and imperfect memories. Modern analysis of ancient mathematical achievements continues to reveal additional layers of sophistication that challenge conventional timelines. Computer modeling of ancient astronomical calculations shows precision that required mathematical techniques equivalent to modern computational methods. Analysis of ancient geometric constructions reveals an understanding of mathematical relationships that weren't formally proved until the development of modern mathematics. The mathematical evidence forces the same conclusion that appeared in construction techniques and astronomical knowledge. Ancient cultures possessed an advanced understanding that couldn't have developed through the gradual accumulation of mathematical discovery. Someone had been teaching sophisticated mathematical principles to civilizations across the ancient world, leaving evidence of their instruction embedded in stone monuments and mathematical texts that survived when the teachers themselves vanished from history. As Vasquez compiled her research, the scope of ancient mathematical knowledge became undeniable. These weren't primitive cultures struggling with basic arithmetic. They were civilizations that possessed mathematical understanding comparable to modern computational capabilities, applied systematically to engineering projects that remain impressive by contemporary standards. The mathematical principles they employed were more sophisticated than necessary for their apparent applications, suggesting theoretical knowledge that far exceeded practical requirements. The numbers that had appeared in Vasquez's dreams weren't random constants accidentally discovered by ancient builders. They were evidence of systematic mathematical instruction by teachers whose own mathematical knowledge remains mysterious. The precision of the calculations, the consistency of the applications, and the sophisticated understanding of mathematical relationships all pointed to advanced mathematical education that had somehow operated across the ancient world. But who possessed such mathematical knowledge 12,000 years ago? How was it transmitted to cultures that supposedly hadn't developed writing systems capable of recording complex mathematical concepts? And why did this advanced mathematical understanding disappear, leaving later civilizations to rediscover principles that ancient cultures had somehow mastered? The mathematical conspiracy embedded in ancient monuments raised questions that challenged every assumption about the development of human knowledge and the true capabilities of our distant ancestors. The revelation struck archaeologist Dr. James Morrison like a physical blow as he stood in the pre-dawn darkness at Sacsayhuaman, watching the first rays of sunlight illuminate the massive stone walls. For 23 years, he had studied megalithic construction across 6 continents, cataloging techniques and analyzing construction methods. But in that moment, as shadows danced across the precisely fitted stones, he realized he had been looking at the evidence all wrong. These weren't different construction techniques developed by separate cultures. They were variations of a single architectural language, signed by builders who had learned from the same master teachers. The signature appeared first in the stones themselves. Morrison had documented the polygonal masonry technique at dozens of sites, but he had always attributed the similarities to practical necessities: earthquake resistance, structural stability, efficient use of irregular stones. Now, examining the walls with a fresh perspective, he recognized something far more specific: a distinctive approach to stone cutting that appeared with identical characteristics wherever megalithic construction occurred. The signature wasn't just in the interlocking shapes or the precision fitting. It was in the subtle details that revealed the hand of specific instruction. The way cornerstones were beveled at precisely 15 degrees. The technique of creating recessed joints that shed water while maintaining structural integrity. The method of alternating stone orientations to distribute stress loads across the entire wall. These weren't intuitive solutions that multiple cultures would independently discover. They were specific techniques that reflected systematic training in advanced masonry principles. Morrison pulled out his field notes from Ollantaytambo, another Peruvian site where the same distinctive techniques appeared. The photographs showed identical beveling angles, the same recessed joint construction, and the same stress distribution patterns. But Ollantaytambo was built by a different culture, at a different time, using stones of different composition. The identical techniques couldn't be explained by environmental factors or material properties. They reflected instruction by builders who had learned identical methods from the same source. The signature extended beyond stone cutting to encompass entire construction philosophies. Ancient megalithic sites demonstrated consistent approaches to foundation design that defied explanation through independent development. The technique of creating foundations that extended far below ground level, using massive stones that were invisible once construction was complete, appeared at sites worldwide. These foundations required enormous additional labor and materials for no apparent structural benefit, yet they appeared consistently across cultures that supposedly had no contact with each other. The underground foundations at Baalbek in Lebanon extended 40 feet below the visible temple platform, using stones that weighed hundreds of tons each. Similar invisible foundations appeared beneath the temple complexes at Angkor Wat, the pyramid platforms at Teotihuacan, and the megalithic circles at Stonehenge. The foundations weren't necessary for structural stability. The visible portions of these monuments would have been perfectly stable on conventional foundations, but the builders had invested enormous additional resources in creating massive underground supports that suggested an understanding of geological principles that wouldn't be formalized for millennia. The acoustic signature provided another distinctive marker of specific instruction. Morrison had documented acoustic properties at megalithic sites across the globe, but he had initially attributed these to accidental byproducts of large stone construction. Now he recognized them as deliberate engineering features that required a sophisticated understanding of sound propagation principles. The acoustic effects weren't random or approximate. They demonstrated precise mathematical relationships between architectural dimensions and sound wavelengths. Chambers that amplified sounds at specific frequencies, galleries that transmitted whispers across impossible distances, and platforms that created echo patterns corresponding to astronomical cycles. These acoustic features required calculations that modern architects perform using computer modeling. Yet they appeared in monuments built by cultures that supposedly lacked mathematical frameworks for such complex engineering. The acoustic signature appeared with identical characteristics at sites separated by vast distances. The king's chamber in the Great Pyramid resonated at the same frequency as acoustic chambers in temples at Malta, Mexico, and Peru. The specific frequency, 110 Hz, wasn't arbitrary. It corresponded to mathematical relationships governing human brainwave patterns and had measurable effects on consciousness and perception. Ancient builders had somehow identified and incorporated acoustic frequencies that modern neuroscience was only beginning to understand. Water management provided yet another distinctive signature of systematic instruction. Ancient megalithic sites demonstrated a sophisticated understanding of hydraulic principles that enabled complex water control systems. But the techniques weren't developed to meet local water needs. They reflected advanced engineering knowledge applied consistently across diverse environments. The hydraulic systems at Machu Picchu employed techniques that appeared identically at sites in Malta, Easter Island, and Cambodia. Channels cut with precise gradients that maintained optimal flow rates across varying terrain. Reservoirs are designed with mathematical relationships that prevent erosion and maintain water quality over centuries. Drainage systems that employed pressure differentials and siphon effects to move water uphill against gravity. These hydraulic features required an understanding of fluid dynamics, materials science, and geological engineering that exceeded practical needs. The water systems were more sophisticated than necessary for the populations they served, suggesting theoretical knowledge that was applied to practical problems rather than developed through trial and error experimentation. The astronomical signature revealed perhaps the most compelling evidence of unified instruction. Ancient megalithic sites incorporated astronomical alignments that demonstrated an identical understanding of celestial mechanics across cultures that supposedly developed independently. But the alignments weren't limited to basic solar and lunar observations. They incorporated sophisticated understanding of planetary cycles, stellar precession, and gravitational effects that required advanced astronomical theory. The alignment techniques appeared with mathematical precision that exceeded observational capabilities. Ancient monuments tracked celestial events with accuracy measured in arc minutes, angular measurements that would be impossible to achieve through naked eye observation alone. The precision required an understanding of atmospheric refraction, gravitational lensing, and other optical effects that weren't recognized until the development of modern astronomy. Stone circles in Britain, temple complexes in Cambodia, and pyramid alignments in Egypt all demonstrated identical astronomical sophistication. The builders had somehow acquired knowledge of celestial mechanics that enabled predictions of planetary positions, eclipse cycles, and stellar configurations thousands of years in advance. This wasn't observational astronomy developed through centuries of skywatching. It was theoretical understanding that anticipated modern astrophysics. The construction logistics revealed another layer of the distinctive signature. Megalithic sites worldwide demonstrated identical approaches to moving and positioning massive stones that defied explanation through independent development. The techniques weren't determined by available materials or local geography. They reflected a systematic understanding of engineering principles that was applied consistently across diverse environments. The method of transporting multi-ton stones over long distances appeared identically at sites where conventional explanations varied dramatically. Whether moving trilithon stones at Stonehenge, transporting Moai statues on Easter Island, or positioning foundation blocks at Baalbek, the logistics demonstrated an identical understanding of mechanical principles, stress distribution, and coordinated labor management. The positioning techniques showed similar consistency. Massive stones were placed with millimeter precision, using methods that required an understanding of surveying, geometric relationships, and structural engineering. The precision wasn't necessary for structural stability. These monuments would have been perfectly functional with conventional positioning tolerance. But the builders had achieved accuracy that exceeded practical requirements, suggesting mastery of engineering principles that went far beyond immediate construction needs. Material selection provided additional evidence of systematic instruction. Ancient megalithic builders demonstrated identical approaches to choosing stones based on acoustic properties, thermal characteristics, and electromagnetic effects. The selections weren't determined by local availability. Builders often transported stones over enormous distances to obtain materials with specific properties. The builders at Stonehenge transported blue stones over 200 miles from Wales, selecting materials with specific acoustic resonance characteristics. Easter Island builders chose different stone types for statue bodies versus topknots, demonstrating an understanding of material properties that affected acoustic and thermal performance. Pyramid builders selected limestone, granite, and basalt for different structural components based on properties related to electromagnetic conductivity and energy transmission. These material choices reflected an understanding of physics principles that wouldn't be formalized until the development of modern materials science. The builders somehow knew which stones would produce specific acoustic effects, thermal properties, and electromagnetic characteristics. This knowledge was applied systematically across sites worldwide, suggesting instruction by teachers who possessed an advanced understanding of materials physics. The tool's signatures provided the most direct evidence of specific instruction. Analysis of tool marks on ancient megalithic stones revealed identical cutting techniques that couldn't be explained by convergent technological development. The marks weren't produced by different tools achieving similar results. They were created by identical tools using identical techniques across sites separated by continents and millennia. Microscopic analysis revealed cutting marks that matched with extraordinary precision. The feed rates, cutting speeds, and tool geometry were identical within measurable tolerances. Modern manufacturing achieves such consistency only through standardized machinery and quality control systems, yet ancient builders produced identical results using techniques that remain mysterious. The tool signature extended beyond cutting marks to encompass entire manufacturing processes. Stone shaping, surface finishing, and joint preparation all demonstrated identical approaches that reflected systematic training in advanced stoneworking techniques. The processes weren't intuitive methods that multiple cultures would independently develop. They were specific procedures that required understanding of material properties, tool dynamics, and quality control principles. As Morrison compiled his evidence, the scope of the distinctive signature became undeniable. Every aspect of megalithic construction, from stone cutting to astronomical alignment to acoustic engineering, bore the marks of unified instruction by teachers who possessed advanced knowledge. The techniques weren't variations developed by different cultures, adapting to local conditions. They were applications of consistent principles taught by instructors whose identity remained mysterious. The signature appeared most clearly in details that served no practical purpose. Decorative elements that required advanced mathematical understanding, acoustic features that exceeded functional requirements, and astronomical alignments that demonstrated theoretical knowledge far beyond observational needs. These elements suggested that the instruction included advanced theoretical frameworks that were applied selectively to practical construction problems. The degradation pattern that appeared in other aspects of ancient knowledge also affected the distinctive signatures. The earliest megalithic sites demonstrated the clearest evidence of unified instruction, with later constructions showing declining consistency, as if built by students working from incomplete training. The signatures became less precise over time, suggesting that the original source of instruction had been gradually lost. Standing in the growing daylight at Sacsayhuaman, Morrison realized that the massive stones surrounding him weren't just evidence of advanced ancient construction techniques. They were textbooks written in stone by master teachers, whose lessons could still be read by those who knew how to look. Every precisely cut joint, every acoustic chamber, every astronomical alignment carried the signature of instructors whose advanced knowledge had somehow reached every corner of the ancient world. But who were these master teachers whose signatures appeared in stone monuments across every continent? And what had happened to the advanced knowledge they had systematically shared with civilizations that were supposedly primitive and isolated? The document that arrived at archaeologist Dr. Lisa Patterson's home at 3 a.m. carried no official seal, bore no government letterhead, but its contents would haunt her for the rest of her career. Slipped through her mail slot by an unknown messenger, the manila folder contained photocopied pages from what appeared to be a classified CIA report dated 1952. The heading read, "Archaeological Discoveries, National Security Implications, Project Buried Truth." What Patterson read in those pages revealed a pattern of systematic suppression that extended far beyond academic disagreements or institutional politics. It exposed a coordinated effort to hide evidence that challenged fundamental assumptions about human history. The report, if authentic, documented dozens of archaeological discoveries that had been classified, buried, or explained away when they threatened established narratives about human development. Advanced artifacts found in geological layers that predate accepted timelines. Construction techniques that exceeded the known capabilities of ancient cultures. Evidence of sophisticated technology in contexts where it supposedly couldn't exist. Each discovery had been quietly removed from public knowledge through methods that ranged from academic pressure to direct government intervention. Patterson's hands trembled as she read the case files. The first entry described the 1947 discovery of metallic artifacts in coal seams dated to 300 million years ago, long before complex life was supposed to exist on Earth. The artifacts had been analyzed by government metallurgists who confirmed their artificial origin and sophisticated alloy composition. But instead of revolutionizing understanding of geological history, the discovery had been classified and the artifacts relocated to undisclosed storage facilities. The pattern continued through dozens of similar cases. Stone tools found in geological contexts that placed them millions of years before accepted timelines for human development. Fossilized human remains discovered in rock formations that predate evolutionary theory by enormous margins. Advanced mechanical devices recovered from archaeological sites that demonstrated technological sophistication impossible according to conventional chronologies. Each discovery had followed the same trajectory: initial excitement from researchers, followed by increasingly intense scrutiny from unnamed authorities, then quiet disappearance from academic literature and public discourse. The researchers involved faced career obstacles, funding cuts, and institutional pressure that effectively ended their ability to pursue similar work. The physical evidence vanished into private collections or government facilities where it remained inaccessible to independent analysis. According to the leaked document, Project Buried Truth had been established to monitor archaeological discoveries that posed security risks to established historical narratives. The project's scope extended beyond simple censorship to include active suppression techniques designed to discredit researchers, confiscate evidence, and manipulate academic institutions to prevent publication of problematic findings. The report detailed specific methods used to suppress unwanted discoveries. Academic journals were pressured to reject papers that challenged established timelines. Research grants were denied to investigators pursuing controversial lines of inquiry. University departments were warned that continued support for problematic research would result in federal funding cuts. Museum collections were audited, and problematic artifacts were quietly removed from public display. Patterson cross-referenced the classified report with her own knowledge of archaeological controversies over the past century. The pattern was undeniable. Discoveries that challenged conventional timelines or suggested advanced ancient capabilities had consistently faced institutional resistance that went far beyond normal academic skepticism. The opposition was systematic, coordinated, and backed by resources that exceeded what academic institutions could mobilize independently. The Kensington runestone, discovered in Minnesota in 1898, provided a clear example of the suppression pattern. The artifact contained runic inscriptions that suggested pre-Columbian European contact with North America, a possibility that challenged established narratives about New World discovery. Despite compelling linguistic and geological evidence supporting its authenticity, the stone faced decades of coordinated attacks that branded it a hoax without addressing the technical evidence that supported its legitimacy. The Bat Creek inscription, found in Tennessee in 1889, faced similar treatment. The stone contained Hebrew inscriptions that predated known Jewish presence in North America by centuries. Linguistic analysis supported the inscription's authenticity, and radiocarbon dating confirmed the artifact's age. But academic institutions refused to acknowledge findings that challenged accepted timelines for transatlantic contact. The Los Alamos stones, discovered in New Mexico in 1982, contained inscriptions in multiple ancient languages, including Hebrew, Greek, and Linear B. The linguistic sophistication and archaeological context suggested contact between Old World civilizations and pre-Columbian America thousands of years before accepted timelines allowed. Despite extensive analysis confirming the inscription's authenticity, the discovery was dismissed as fraudulent without adequate scientific investigation. According to the leaked report, these dismissals weren't based on scientific analysis. They were policy decisions designed to maintain historical narratives that served institutional interests. Advanced archaeological discoveries threatened not just academic theories, but entire frameworks of understanding that supported political and economic systems. If human civilization was far older and more sophisticated than conventional history suggested, then current institutions might not represent the pinnacle of human achievement, but rather a recovery phase from catastrophic knowledge loss. The suppression extended beyond individual artifacts to encompass entire archaeological sites. The report documented cases where excavations had been terminated when discoveries threatened established chronologies. Sites had been declared off-limits to researchers, buried under construction projects, or simply abandoned when findings challenged conventional timelines. Göbekli Tepe in Turkey provided a perfect example of selective revelation. The site's official discovery in 1994 revealed construction that predated accepted timelines for complex architecture by thousands of years. But according to the leaked document, the site had been known to authorities since the 1960s. The delayed official recognition allowed time to develop explanatory frameworks that minimized the discovery's revolutionary implications. The report suggested that many sites remained undisclosed or underreported when discoveries challenged established narratives too severely. Archaeological surveys were designed to avoid areas where problematic evidence might surface. Excavation permits were denied for sites that posed risks to conventional chronologies. Research funding was directed toward investigations that supported rather than challenged accepted theories. International cooperation appeared to be a key component of the suppression effort. The document described coordination between American agencies and foreign institutions to ensure consistent policies regarding problematic discoveries. Archaeological evidence that surfaced in one country could be suppressed through pressure applied by partner institutions in other nations. The Vatican archives were specifically mentioned as a repository for artifacts that challenged conventional religious and historical narratives. Ancient texts, advanced technological artifacts, and archaeological evidence of pre-Diluvian civilizations had allegedly been collected and stored in facilities that remained inaccessible to independent researchers. The Church's vast resources and international influence made it an ideal partner for suppression efforts that required long-term storage and absolute secrecy. Private collections also played a crucial role in removing problematic evidence from public scrutiny. Wealthy collectors, often working in coordination with government agencies, purchased artifacts that posed challenges to established narratives. Once in private hands, the artifacts could be studied by authorized researchers while remaining inaccessible to investigators who might reach unwanted conclusions. The suppression methods weren't limited to physical artifacts. The report documented systematic efforts to control academic discourse through funding mechanisms, publication policies, and career incentives. Researchers who pursued problematic lines of inquiry faced obstacles that effectively ended their careers, while those who supported conventional narratives received institutional support and professional advancement. Graduate students were particularly vulnerable to pressure. Dissertation topics that challenged established chronologies were discouraged or prohibited. Students who persisted in controversial research found themselves unable to secure academic positions regardless of their research quality. The message was clear. Careers in archaeology required adherence to acceptable interpretations of human history. Professional conferences and academic journals served as gatekeepers that prevented problematic research from reaching broader audiences. Papers that challenged conventional timelines faced rejection regardless of their methodological rigor. Conference presentations that suggested advanced ancient capabilities were relegated to fringe sessions or excluded entirely. The peer review process became a mechanism for enforcing orthodoxy rather than evaluating scientific merit. Media coverage of archaeological discoveries was also subject to coordination and control. The report described relationships between government agencies and major news organizations that ensured problematic discoveries received minimal coverage or were presented in ways that minimized their significance. Sensational interpretations were encouraged when they discredited legitimate research, while serious scientific analysis was downplayed or ignored. The suppression effort required enormous resources and institutional coordination that extended far beyond what academic disagreements would warrant. Government agencies, religious institutions, academic organizations, and media corporations had somehow aligned their policies to prevent public awareness of archaeological evidence that challenged conventional historical narratives. Patterson realized that the coordination suggested powerful interests whose authority depended on maintaining specific interpretations of human history. If advanced civilizations had existed in the distant past, then current institutions might not represent the pinnacle of human achievement. If sophisticated knowledge had been lost through catastrophic events, then modern civilization might be more fragile than generally assumed. If alternative historical narratives were valid, then entire frameworks of political and economic power might require fundamental reconsideration. The leaked report provided specific examples of suppression techniques that Patterson recognized from her own experience. Colleagues whose careers had been mysteriously derailed after pursuing controversial research, funding decisions that seemed to bypass normal evaluation criteria, museum exhibitions that were cancelled without adequate explanation, academic papers that disappeared from publication schedules despite acceptance by journal editors. The evidence suggested that archaeological suppression wasn't a conspiracy theory. It was documented policy implemented through institutional mechanisms that operated with systematic efficiency. The suppression wasn't driven by scientific concerns about methodological rigor or interpretive accuracy. It was motivated by political considerations about maintaining historical narratives that supported established power structures. As dawn broke outside Patterson's window, she faced a choice that would define the remainder of her career. The document in her hands provided evidence of systematic suppression that extended far beyond academic politics into realms of national security and institutional control. If the leaked report was authentic, then decades of archaeological discoveries had been hidden from public knowledge through coordinated efforts that involved government agencies, religious institutions, and academic organizations. But revealing the suppression would mean challenging not just scientific orthodoxy, but entire systems of institutional authority. It would mean confronting evidence that human history was far stranger and more complex than conventional narratives suggested. Most dangerously, it would mean acknowledging that current civilization might not represent the pinnacle of human development, but rather a recovery phase from catastrophic loss of knowledge that had been systematically hidden from public awareness. The morning light illuminated the pages spread across Patterson's desk, each document a testament to discoveries that had been deemed too dangerous for public knowledge. Somewhere in classified storage facilities and private collections, evidence waited that could revolutionize understanding of human history, if anyone possessed the courage to bring it into the light. But who could be trusted with such evidence when the suppression effort involved the very institutions that society depended upon for truth and knowledge? The ice core samples told a story that geologist Dr. Michael Hoffman wished he could ignore. Extracted from the Greenland ice sheet at depths corresponding to 12,800 years ago, the cylindrical sections of frozen time contained evidence of a global catastrophe so severe it had reshaped the planet's climate, geography, and biological systems within a matter of decades. As Hoffman studied the chemical composition under laboratory lights in his Colorado research facility, the data painted a picture of destruction that coincided precisely with the mysterious disappearance of advanced construction techniques, mathematical knowledge, and architectural sophistication from the archaeological record. The ice cores revealed atmospheric conditions that defied conventional understanding of gradual climate change. Within a span of less than 50 years, global temperatures had plummeted by 15 degrees Celsius. Atmospheric dust levels had increased by orders of magnitude, suggesting massive volcanic activity or impact events. Chemical signatures indicated unprecedented levels of cosmic radiation reaching Earth's surface, as if the planet's magnetic field had been severely disrupted or temporarily collapsed. But the ice cores were only the beginning of a geological puzzle that extended across every continent. Hoffman had spent 3 years correlating climate data from sources worldwide, and the pattern that emerged suggested a catastrophe of almost unimaginable scope. Ocean sediment cores from the Atlantic, Pacific, and Indian Oceans all showed identical disruption patterns at the same chronological horizon. Volcanic ash layers, impact debris, and biological extinction markers appeared simultaneously in geological records separated by thousands of miles. The Younger Dryas period, as climatologists had labeled this mysterious cold snap, represented one of the most dramatic climate reversals in Earth's recent history. Temperatures that had been warming steadily for millennia suddenly reversed, plunging the planet back into near glacial conditions that persisted for over 1,000 years. The change wasn't gradual. It happened within decades, faster than any natural climate variation scientists had previously documented. Traditional explanations for the Younger Dryas focused on changes in ocean circulation patterns caused by glacial meltwater, disrupting thermohaline circulation in the North Atlantic. But Hoffman's analysis revealed problems with this theory that mainstream climatology refused to acknowledge. The temperature changes were too rapid, too globally synchronized, and too severe to be explained by oceanic circulation alone. The chemical signatures in ice cores suggested causes that extended far beyond Earth's atmospheric and oceanic systems. Evidence of cosmic impact began appearing in geological layers corresponding to the onset of the Younger Dryas. Microscopic diamonds, formed only under extreme pressure and temperature conditions, appeared in sediment samples from sites across North America, Europe, and Asia. The diamonds weren't randomly distributed. They appeared in a thin layer that corresponded precisely to the beginning of the climate catastrophe, suggesting formation through a single planet-wide event of extraordinary violence. Nanodiamonds weren't the only exotic materials found in the 12,800-year-old boundary layer. Spherules of melted rock, formed at temperatures exceeding 2,000 degrees Celsius, appeared in the same geological horizon. Carbon spherules created through the incomplete combustion of organic materials suggested massive wildfires that had burned across continents simultaneously. The materials were distributed globally, indicating an event that had affected the entire planet within a very short time frame. The impact hypothesis faced fierce resistance from mainstream geology, but the evidence continued to accumulate. Shocked quartz, mineral formations that occur only under the extreme pressures generated by cosmic impacts, appeared in boundary layer samples from multiple continents. The quartz crystals showed deformation patterns identical to those found at confirmed impact sites, like the Chicxulub crater associated with dinosaur extinction. Iridium anomalies provided additional support for the impact theory. The rare metal, uncommon in Earth's crust, but abundant in asteroids and comets, appeared in elevated concentrations in sediment layers corresponding to the Younger Dryas onset. The iridium spikes weren't localized. They appeared in geological samples from sites worldwide, suggesting global distribution of extraterrestrial material. The biological evidence painted an equally catastrophic picture. Pollen records from around the world showed massive vegetation die-offs at the onset of the Younger Dryas. Forests that had flourished for millennia disappeared within decades, replaced by cold, adapted species that indicated dramatic temperature reductions. The vegetation changes weren't gradual adaptations to cooling conditions. They represented wholesale ecosystem collapse and replacement. Megafauna extinctions provided the most dramatic evidence of catastrophic change. Large mammals that had survived previous climate variations suddenly disappeared from the fossil record at the Younger Dryas boundary. Woolly mammoths, saber-toothed cats, giant ground sloths, and dozens of other species vanished simultaneously across multiple continents. The extinctions weren't spread over millennia, they occurred within centuries, suggesting rapid environmental changes that exceeded the species' ability to adapt. Archaeological evidence revealed that human populations were equally affected by the catastrophe. Settlement patterns showed massive population disruptions at the Younger Dryas onset. Advanced cultures that had been developing sophisticated technologies suddenly reverted to simpler survival strategies. The archaeological record suggested not just climate stress, but complete cultural collapse across regions that had been experiencing technological advancement. The timing of the catastrophe coincided precisely with the mysterious disappearance of advanced construction techniques from the archaeological record. Megalithic building methods that had appeared simultaneously around the world suddenly vanished from human capabilities. Mathematical knowledge that had enabled sophisticated astronomical calculations disappeared from cultural traditions. Engineering techniques that had produced precision stone cutting were forgotten across multiple civilizations. The correlation wasn't coincidental. The advanced knowledge that had characterized pre-Younger Dryas cultures required stable populations, accumulated learning, and institutional continuity that catastrophic climate change would have destroyed. When temperatures plummeted and ecosystems collapsed, the cultural infrastructure necessary to maintain sophisticated knowledge would have collapsed as well. Hoffman's analysis suggested that the catastrophe had been more severe than climate data alone indicated. The cosmic impact hypothesis explained not just temperature changes, but the complete disruption of advanced human cultures. If Earth had been struck by fragments of a disintegrating comet or asteroid, the immediate effects would have included massive fires, atmospheric darkening, and rapid climate change that would have overwhelmed any human civilization, regardless of its technological sophistication. The impact wouldn't have required a single massive collision. Computer modeling suggested that a fragmented comet breaking apart in the inner solar system could have subjected Earth to multiple impacts over several decades. The repeated bombardment would have prevented recovery between individual strikes, creating sustained catastrophic conditions that persisted until the impacting debris was exhausted. Evidence for multiple impacts appeared in geological records from around the world. Rather than a single boundary layer marking a catastrophic event, many sites showed multiple disruption horizons spanning several decades. The pattern suggested sustained bombardment that would have made recovery impossible for human cultures that depended on stable environmental conditions. The geographic distribution of impact evidence suggested that North America had been particularly severely affected. The highest concentrations of exotic materials, the most dramatic vegetation changes, and the most complete megafauna extinctions all occurred in regions that would have been directly exposed to impacts from fragments arriving from space. European and Asian sites showed severe effects, but less direct evidence of impact, suggesting that some regions had been affected primarily by secondary consequences rather than direct strikes. Archaeological evidence supported the hypothesis that North American advanced cultures had been completely destroyed by the catastrophe. The Clovis culture, which had demonstrated sophisticated tool-making techniques and had been expanding across the continent, disappeared abruptly from the archaeological record at the Younger Dryas boundary. Later cultures showed no continuity with Clovis traditions, suggesting complete cultural disruption rather than gradual change. Similar patterns appeared worldwide. Advanced cultures that had been developing sophisticated technologies suddenly vanished from the archaeological record. The cultural knowledge that had enabled precision construction, advanced mathematics, and sophisticated astronomy disappeared so completely that later civilizations had to redevelop these capabilities from first principles, a process that took millennia and never fully recovered the precision that had characterized pre-catastrophe achievements. The global mythology of flood stories suddenly made sense in the context of cosmic impact. Cultures around the world preserved traditions of global catastrophes involving fire from the sky, worldwide flooding, and the destruction of advanced civilizations. These weren't metaphorical descriptions of gradual climate change. They were cultural memories of actual catastrophic events that had shaped human history. The biblical flood narrative, the Hindu accounts of cyclic destruction, the Hopi prophecies of world-ending fire, and dozens of other cultural traditions all described catastrophes that matched the evidence emerging from geological and archaeological research. The stories weren't mythology, they were historical accounts preserved through the oral tradition of events that had actually occurred. The recovery period following the catastrophe explained the mysterious reappearance of advanced techniques in later civilizations. As climate conditions stabilized and human populations recovered, remnants of pre-catastrophe knowledge began to resurface. But the knowledge was fragmentary, passed down through survivors who had preserved only portions of the original understanding. This explained why advanced construction techniques appeared suddenly in post-catastrophe civilizations without evidence of gradual development. The builders weren't inventing new methods, they were reconstructing techniques that had been lost during the catastrophic period. The precision and sophistication of the earliest post-catastrophe monuments reflected a partial recovery of knowledge that had once been more complete and systematic. The degradation pattern that appeared in construction techniques over time made sense as evidence of incomplete knowledge transmission. Each generation of builders possessed a less complete understanding than their predecessors, working from fragmentary instructions and imperfect memories of techniques they couldn't fully comprehend. Without the theoretical frameworks that had originally enabled the advanced methods, the practical applications inevitably declined in precision and sophistication. As Hoffmann compiled his research, the scope of the catastrophe became undeniable. The Younger Dryas wasn't just a climate event, it was a civilization-ending catastrophe that had destroyed advanced human cultures and scattered their survivors across a devastated planet. The impact had ended a period of rapid technological development and forced humanity into a dark age from which recovery took millennia. The evidence suggested that human civilization was far older and had achieved far greater sophistication than conventional history acknowledged. But it also revealed how fragile that civilization had been when confronted with cosmic catastrophe. The advanced knowledge that had enabled precision construction, sophisticated mathematics, and complex astronomy had been lost almost instantly when the environmental and social conditions necessary to maintain it were destroyed. The morning light filtering through Hoffmann's laboratory windows illuminated ice core samples that contained evidence of humanity's forgotten past. Locked in frozen layers of ancient atmosphere was proof that advanced civilization had risen and fallen long before recorded history began. But the same evidence also revealed the cosmic forces that could destroy such civilizations without warning, leaving only scattered fragments of knowledge for future generations to rediscover. What remained unclear was whether the catastrophe had been entirely natural or whether other factors had contributed to the destruction of pre-flood civilization. The precision timing, the global scope, and the complete elimination of advanced knowledge suggested events that might have exceeded even cosmic impact in their thoroughness and devastating effects. The ancient manuscript arrived at Professor Catherine Blackwood's office through channels that defied academic protocol. No publisher's mark, no library stamp, no provenance documentation. Just a leather-bound volume that appeared on her desk at Oxford University with a handwritten note. The survivors preserved what they could. As a specialist in medieval mystery traditions, Blackwood had encountered countless historical texts, but the pages before her contained knowledge that shouldn't have existed for centuries after their supposed composition date. The manuscript claimed to be a copy of instructions preserved by survivors of a great catastrophe, transcribed in the 13th century from sources that were already ancient beyond memory. The text described geometric principles for stone cutting, astronomical calculations for predicting celestial events, and engineering techniques for creating structures that would survive geological upheavals. But what made the document extraordinary wasn't its content. It was the precision of knowledge that matched exactly the capabilities demonstrated at megalithic sites worldwide. Blackwood cross-referenced the manuscript's geometric diagrams with measurements from Stonehenge, Machu Picchu, and the Great Pyramid. The mathematical relationships were identical down to decimal places that medieval scholars supposedly couldn't calculate. The astronomical tables enabled predictions of eclipse cycles, planetary conjunctions, and stellar alignments with accuracy that wouldn't be achieved by European astronomy until the Renaissance. The engineering instructions described techniques for cutting and positioning massive stones, using methods that modern archaeologists claimed were impossible with ancient tools. The manuscript wasn't unique. As Blackwood researched similar texts, she discovered a hidden tradition of knowledge preservation that extended across cultures and centuries. Mystery schools in Egypt, Greece, and Mesopotamia had maintained libraries of ancient wisdom that predated their own civilizations. Hermetic traditions in medieval Europe preserved mathematical and astronomical knowledge through symbolic systems that concealed advanced understanding within apparently mystical teachings. The Knights Templar provided perhaps the clearest example of systematic knowledge preservation. Founded officially as a military order during the Crusades, the Templars had acquired access to ancient libraries in Jerusalem that contained texts predating Christianity by millennia. According to the manuscript on Blackwood's desk, these libraries held fragmentary records of pre-catastrophe civilization, including architectural plans, astronomical calculations, and engineering techniques that the Templars had secretly preserved and applied to their own construction projects. Gothic cathedral construction suddenly made sense as evidence of recovered ancient knowledge. The mathematical precision of cathedral proportions, the sophisticated understanding of structural engineering, and the acoustic properties of sacred spaces all reflected capabilities that exceeded what medieval builders supposedly possessed. The cathedrals weren't innovations, they were reconstructions based on fragmentary instructions preserved from pre-catastrophe sources. The manuscript described how knowledge had been deliberately encoded in cathedral architecture to preserve it for future generations. Mathematical relationships were embedded in structural proportions. Astronomical alignments were built into foundation orientations. Acoustic principles were incorporated into vault designs. The cathedrals served as three-dimensional textbooks that would survive even if the written instructions were lost. Similar preservation techniques appeared in other mystery traditions. Islamic geometric patterns contained mathematical relationships that encoded advanced knowledge in decorative forms. Hindu temple architecture incorporated astronomical alignments and proportional systems that preserved ancient astronomical understanding. Chinese feng shui principles maintained geological and astronomical knowledge through landscape design systems that appeared to be aesthetic preferences but actually represented sophisticated environmental science. The preservation wasn't random or haphazard. The manuscript revealed that survivors of the Great Catastrophe had deliberately established institutions designed to maintain ancient knowledge through periods of cultural darkness. Mystery schools, religious orders, and craft guilds all served as repositories for fragments of pre-catastrophe understanding that would otherwise have been lost completely. The Freemasons provided the most systematic example of knowledge preservation through institutional tradition. The organization's rituals, symbols, and architectural teachings contained encoded references to construction techniques, geometric principles, and astronomical knowledge that predated the guild system by millennia. The Masonic degrees represented a curriculum of ancient wisdom transmitted through symbolic instruction that concealed advanced knowledge within apparently ceremonial activities. Masonic symbols revealed their true significance when understood as remnants of pre-catastrophe knowledge systems. The square and compass represented geometric principles for precise construction. The all-seeing eye symbolized astronomical observation techniques. The pyramid and other architectural motifs referred to specific construction methods that had been preserved through symbolic transmission when written records were lost. The preservation techniques extended beyond European traditions to encompass global knowledge-keeping systems. Native American medicine wheels encoded astronomical calculations in stone circle arrangements that preserved calendar systems more sophisticated than anything attributed to pre-Columbian cultures. Aboriginal Australian songlines maintained geographical and astronomical knowledge through oral traditions that could navigate vast distances using celestial references and geological markers. Polynesian navigation techniques demonstrated preserved knowledge that enabled transoceanic voyages using star positions, wave patterns, and weather signs. The navigational understanding exceeded what conventional history attributed to prehistoric cultures, suggesting preservation of ancient seafaring knowledge that had been developed when ocean levels and climate conditions were different from those encountered by later Polynesian voyagers. The manuscript described how knowledge preservation required a careful balance between concealment and transmission. Information had to be hidden from authorities who might suppress it, while remaining accessible to initiates who could understand its significance. This led to encoding systems that preserved ancient knowledge within religious traditions, craft techniques, and cultural practices that appeared harmless to outside observers. Alchemical traditions provided perfect examples of knowledge concealment. The symbolic language of alchemy appeared to describe mystical transformations of base metals into gold, but the coded instructions actually preserved chemical knowledge, metallurgical techniques, and pharmaceutical understanding that had survived from pre-catastrophe sources. The alchemical laboratory became a cover for maintaining scientific knowledge during periods when such understanding was considered dangerous or heretical. Medieval illuminated manuscripts contained similar encoded preservation. Mathematical diagrams were disguised as religious illustrations. Astronomical charts were hidden within decorative borders. Engineering principles were encoded in architectural drawings that appeared to be artistic representations rather than technical instructions. The manuscripts served as hidden textbooks that preserved ancient knowledge while appearing to conform to religious or artistic conventions. The preservation techniques required a sophisticated understanding of human psychology and social dynamics. Knowledge had to be transmitted in forms that would appeal to students while concealing its true significance from hostile authorities. This led to teaching methods that used symbolism, ritual, and gradual revelation to transmit complex understanding through stages of initiation that protected both the knowledge and its keepers. The Rosicrucian tradition demonstrated how mystery schools maintained ancient knowledge through periods of persecution and cultural suppression. The organization's manifestos claimed to preserve wisdom from ancient Egyptian and Greek sources, but the mathematical and scientific knowledge they transmitted exceeded what classical civilizations had supposedly achieved. The Rosicrucians were preserving fragments of pre-catastrophe understanding that had been encoded in symbolic systems designed to survive cultural upheavals. Blackwood's research revealed that knowledge preservation hadn't been limited to European mystery traditions. Similar systems had operated independently across multiple cultures, suggesting coordinated efforts by catastrophe survivors to maintain ancient wisdom through diverse institutional channels. Islamic Sufism, Hindu Tantra, Buddhist esoteric traditions, and Chinese Taoism all contained encoded knowledge that appeared to derive from common pre-catastrophe sources. The encoding systems showed remarkable consistency across cultures that supposedly had no contact with each other. Geometric patterns, numerical relationships, and symbolic structures appeared in mystery traditions from Tibet to Peru to Ireland, suggesting that knowledge preservation had followed systematic methods developed by the original catastrophe survivors. The consistency implied coordination between widely separated knowledge-keeping institutions. Sacred texts provided another layer of knowledge preservation that operated independently of mystery school traditions. Religious scriptures contained encoded references to advanced knowledge that had been disguised as spiritual teachings. The measurements given for Solomon's temple, for example, incorporated mathematical relationships that enabled sophisticated architectural calculations. The dimensions weren't arbitrary religious symbols. They were technical specifications preserved within scriptural authority. Similar encoding appeared in other religious traditions. Hindu scriptures contained astronomical calculations disguised as mythological narratives. Buddhist texts included mathematical sequences presented as spiritual numerology. Islamic texts preserved geometric principles within discussions of divine proportions. The encoding enabled knowledge preservation within religious authority that would protect it from secular suppression. The manuscript on Blackwood's desk contained specific examples of how ancient knowledge had been preserved through institutional channels that operated over centuries. Construction guilds maintained technical knowledge through apprenticeship systems that transmitted advanced techniques while concealing their pre-catastrophe origins. Monastic orders preserved libraries of ancient texts while presenting themselves as religious rather than scientific institutions. The preservation techniques had been remarkably successful. Mathematical knowledge that enabled Gothic cathedral construction, astronomical understanding that predicted celestial events with precision, and engineering capabilities that produced impossible stone-cutting accuracy had all survived the catastrophe and cultural dark ages through institutional preservation systems. The knowledge appeared suddenly in medieval civilization, not because it was newly developed, but because it was being recovered from ancient sources. But the preservation came at enormous cost. The original theoretical frameworks that had enabled systematic understanding were lost, leaving only fragmentary practical applications. Later generations could apply preserved techniques without fully understanding the principles that made them work. This led to declining precision over time as knowledge keepers worked from incomplete instructions that they couldn't fully comprehend. The degradation pattern that appeared in construction techniques, mathematical precision, and astronomical accuracy reflected the limitations of knowledge preservation through institutional channels. Without a complete understanding of the underlying principles, each generation possessed less capability than their predecessors. The preserved knowledge was like machinery that could be operated but not maintained or improved. The institutional preservation systems themselves faced constant threats from authorities who recognized that ancient knowledge posed challenges to established power structures. Mystery schools were periodically suppressed, their libraries destroyed, and their members persecuted. Knowledge-keeping institutions had to continuously adapt their concealment methods to survive in changing political and religious environments. The Templars' destruction provided a clear example of how knowledge preservation efforts faced systematic suppression. When the Order became too wealthy and powerful, secular and religious authorities coordinated their elimination through charges of heresy and conspiracy. The Templars' libraries were scattered, their records destroyed, and their knowledge preservation systems dismantled through violent persecution. Similar suppression efforts targeted other knowledge-keeping institutions throughout history. Gnostic traditions were eliminated by early Christianity. Islamic libraries were destroyed during the Mongol invasions. Cathar communities were exterminated by medieval crusades. Hermetic traditions faced systematic persecution during the Inquisition. Each suppression effort eliminated irreplaceable fragments of preserved ancient knowledge. As Blackwood studied the manuscript's final pages, she realized that knowledge preservation continued into the modern era through institutions that had adapted their concealment methods to contemporary conditions. Scientific societies, archaeological organizations, and academic institutions all contained individuals who maintained awareness of ancient knowledge while publicly supporting conventional historical narratives. The morning light streaming through her Oxford office windows illuminated pages that contained evidence of humanity's longest-running secret: the systematic preservation of pre-catastrophe knowledge through institutions designed to survive cultural upheavals and political persecution. The survivors had succeeded in maintaining fragments of ancient wisdom, but the cost had been enormous and the success only partial. The manuscript ended with a warning that knowledge preservation faced new threats in the modern era. As global communication systems enabled unprecedented surveillance and control, the traditional methods of concealment that had protected ancient knowledge for millennia were becoming ineffective. the Knowledge Keepers faced a choice: reveal their preserved wisdom or watch it disappear forever under modern systems of institutional control that exceeded anything previous suppressors had achieved. But revealing the knowledge meant confronting the same forces that had systematically suppressed evidence of advanced pre-catastrophe civilization for centuries. The battle between knowledge preservation and institutional control was entering a new phase where the stakes included not just fragments of ancient wisdom, but the future of human understanding itself. The breakthrough came to engineer Dr. Robert Hayes while standing in the shadow of the Great Pyramid at 4 in the morning, watching the constellation Orion reach its zenith directly above the monument's apex. For 15 years, Hayes had studied ancient construction techniques with the growing conviction that post-catastrophe civilizations hadn't been developing new technologies. They had been desperately attempting to reconstruct capabilities that had been lost during the Great Catastrophe. But it wasn't until that moment, seeing the stellar alignment that connected Earth to cosmos with mathematical precision, that he understood the true scope of humanity's reconstruction project. The pyramid wasn't just a tomb or a temple, it was a working model of lost knowledge, built by people who possessed fragmentary instructions for capabilities they could no longer fully comprehend. Every measurement, every angle, every internal chamber represented an attempt to recreate understanding that had once enabled far greater achievements. The builders had succeeded in producing an impressive monument, but Hayes realized they had been working from incomplete blueprints for technologies that exceeded their theoretical understanding. Hayes pulled out his notebook and began sketching the connections that had suddenly become clear. Post-catastrophe civilizations showed identical patterns of technological development that suggested systematic reconstruction efforts rather than independent innovation. Advanced capabilities appeared suddenly in the archaeological record, achieved high levels of sophistication within centuries, then gradually degraded over time as if the original instructions were being lost or corrupted. Egyptian pyramid construction provided the clearest example of reconstruction, followed by degradation. The earliest pyramids demonstrated the highest level of mathematical precision, astronomical alignment, and engineering sophistication. Later pyramids showed declining accuracy and simplified construction techniques. By the New Kingdom, Egyptian builders were using crude stone stacking methods that bore little resemblance to the precision demonstrated in earlier monuments. The pattern wasn't unique to Egypt. Across every post-catastrophe civilization, the earliest examples of advanced construction showed the greatest sophistication, with later works demonstrating progressive decline in precision and capability. The builders weren't improving their techniques through experience. They were losing understanding of methods they had initially possessed in more complete form. Hayes had documented this reverse development pattern at sites worldwide. The earliest Mesopotamian ziggurats showed more sophisticated engineering than later examples. The first Greek temples demonstrated mathematical relationships that became less precise in subsequent construction. Chinese pagodas from the earliest periods exhibited structural techniques that later builders couldn't replicate. Everywhere, advanced capabilities appeared fully formed, then degraded over successive generations. The degradation suggested that post-catastrophe builders had been working from instructional materials that they didn't fully understand. They could follow preserved directions to achieve impressive results, but without complete theoretical knowledge, they couldn't maintain or improve upon the original techniques. Each generation possessed less understanding than their predecessors, leading to inevitable quality decline. Archaeological evidence supported the reconstruction hypothesis through discoveries of what appeared to be ancient technical manuals, stone tablets, papyrus scrolls, and carved instructions contained step-by-step directions for construction techniques, mathematical calculations, and engineering procedures that exceeded the apparent knowledge of their creators. The manuals were detailed enough to enable sophisticated construction, but they assumed an underlying theoretical understanding that the post-catastrophe builders apparently lacked. The Egyptian mathematical papyri provided perfect examples of reconstruction instruction manuals. The documents contained precise formulas for calculating pyramid volumes, determining stone cutting angles, and achieving astronomical alignments. But the mathematical techniques were presented as cookbook recipes rather than derived from first principles. The builders could apply the formulas successfully without understanding the mathematical theory that made them work. Similar instructional materials appeared in other post-catastrophe civilizations. Mesopotamian cuneiform tablets contained architectural specifications, astronomical tables, and engineering calculations that enabled sophisticated construction projects. But the texts showed no evidence of mathematical development or theoretical advancement. They were practical manuals that preserved ancient knowledge without explaining its underlying principles. Chinese construction texts from the Han Dynasty contain detailed instructions for advanced engineering techniques, but they were presented as traditional methods passed down from ancient masters rather than innovations developed through contemporary research. The texts assumed knowledge that wasn't explained within their pages, suggesting that they were condensed versions of more complete instructional systems that had been lost. The reconstruction project extended beyond construction techniques to encompass entire knowledge systems that post-catastrophe civilizations attempted to recover. Mathematical understanding, astronomical knowledge, medical techniques, and metallurgical skills all showed the same pattern of sudden appearance, followed by gradual degradation that characterized the reconstruction of lost capabilities rather than the development of new ones. Mesopotamian astronomy provided clear evidence of knowledge reconstruction rather than gradual development. Babylonian astronomical texts contained mathematical techniques for predicting planetary positions, calculating eclipse cycles, and tracking stellar movements with precision that exceeded their apparent theoretical knowledge. The calculations were presented as traditional methods inherited from earlier sources rather than innovations developed through contemporary observation and analysis. The astronomical knowledge appeared suddenly in complete form rather than developing gradually through observational refinement. The earliest Babylonian astronomical texts contained the most sophisticated calculations, with later documents showing simplified methods that suggested loss of understanding rather than technological advancement. The astronomers were reconstructing ancient knowledge rather than developing new observational techniques. Greek mathematics showed similar evidence of reconstruction from ancient sources rather than original theoretical development. The earliest Greek mathematical texts contained advanced geometric principles, algebraic techniques, and computational methods that appeared without mathematical derivation or theoretical explanation. Later Greek mathematicians spent centuries trying to prove theorems that earlier sources had simply stated as established facts. The mathematical knowledge seemed to come from external sources rather than indigenous Greek development. Pythagoras, Thales, and other early Greek mathematicians all claimed to have learned their techniques from Egyptian and Mesopotamian sources that possessed ancient wisdom. The Greeks were translating and interpreting preserved knowledge rather than creating new mathematical understanding through original research. Egyptian medicine provided another example of reconstruction from ancient sources. The earliest Egyptian medical papyri contained surgical techniques, anatomical knowledge, and pharmaceutical preparations that exceeded what contemporary Egyptian civilization could have developed through independent research. The medical knowledge appeared fully formed in the earliest texts, with later documents showing simplified procedures that suggested declining understanding. The medical texts referenced ancient sources and traditional methods that predated the documents themselves. The Edwin Smith Papyrus contained surgical procedures for brain surgery, spinal injuries, and complex fractures that required anatomical knowledge comparable to modern medical understanding. But the techniques were presented as ancient wisdom rather than contemporary medical innovations. Metallurgical knowledge showed the same reconstruction pattern across multiple civilizations. Advanced bronze alloys, steel production techniques, and precision casting methods appeared suddenly in the archaeological record, achieved high levels of sophistication, then gradually declined in quality and complexity. The metallurgical knowledge seemed to be recovered from ancient sources rather than developed through experimental research. Damascus steel production provided a perfect example of reconstructed knowledge that was eventually lost completely. The steel's unique properties resulted from manufacturing techniques that required understanding of carbon chemistry, temperature control, and alloy composition that exceeded medieval theoretical knowledge. The techniques were passed down through master-apprentice traditions that preserved practical methods without theoretical understanding. When the master-apprentice chains were broken through political upheavals and cultural disruptions, the knowledge was lost completely. Later attempts to recreate Damascus steel failed because the reconstructors lacked the theoretical frameworks necessary to understand why the ancient techniques worked. The knowledge had been preserved through practical tradition rather than scientific understanding. Hayes realized that the reconstruction project represented humanity's greatest sustained effort to recover lost capabilities. Post-catastrophe civilizations had dedicated enormous resources to recreating technologies they could no longer fully comprehend. The effort had achieved remarkable success in recovering practical applications of ancient knowledge, but it had failed to restore the theoretical understanding that would have enabled further advancement. The limitations of reconstruction became apparent when post-catastrophe civilizations attempted to exceed their preserved instructional materials. Without complete theoretical knowledge, they couldn't adapt ancient techniques to new applications or improve upon original designs. They were limited to variations of established patterns rather than genuine innovation that built upon ancient foundations. This explained why post-catastrophe achievements, though impressive, never surpassed the precision and sophistication demonstrated at the earliest sites. The Great Pyramid remained unmatched by later Egyptian construction. Stonehenge showed mathematical relationships that weren't equaled in subsequent British monuments. The earliest Greek temples contained proportional systems that later architects couldn't improve upon. The reconstruction project also explained why advanced knowledge appeared simultaneously across multiple post-catastrophe civilizations. The preserved instructional materials had been distributed globally by catastrophe survivors who established knowledge-keeping institutions in different regions. As post-catastrophe populations recovered sufficiently to support sophisticated construction projects, they gained access to similar ancient instructions that enabled comparable achievements. But the distribution was incomplete, and the instructions were fragmentary. Different regions possessed different portions of the original knowledge, leading to variations in emphasis and capability. Egyptian builders excelled at mathematical precision. Mesopotamian astronomers developed computational techniques. Greek mathematicians focused on geometric principles, and Chinese engineers emphasized structural innovation. Each civilization was working from different fragments of the same ancient knowledge base. The reconstruction project's ultimate failure became apparent as ancient instructional materials were gradually lost through cultural disruptions, political upheavals, and institutional collapse. Without the theoretical understanding necessary to preserve and transmit complex knowledge, post-catastrophe civilizations couldn't maintain their reconstructed capabilities indefinitely. The knowledge degraded over successive generations until only crude approximations of original techniques remained. The pattern repeated across every post-catastrophe civilization. Advanced capabilities that had been successfully reconstructed from ancient sources gradually declined in precision and sophistication. Construction techniques became less accurate, mathematical knowledge became simplified, and astronomical understanding became approximate. The reconstruction project succeeded for limited periods but couldn't achieve permanent restoration of pre-catastrophe capabilities. Modern civilization showed similar evidence of reconstruction from ancient sources rather than independent technological development. Scientific knowledge that appeared during the Renaissance often represented the recovery of ancient understanding rather than original discovery. Mathematical principles, astronomical techniques, and engineering methods that emerged during the scientific revolution frequently paralleled capabilities that ancient sources had described, but that medieval civilization had lost. As dawn broke over the pyramid complex, Hayes realized that humanity's reconstruction project continued into the modern era. Contemporary civilization was still working to recover capabilities that pre-catastrophe civilization had achieved more completely. The ancient monuments surrounding him weren't just impressive achievements by primitive builders, they were textbooks left by people who had been desperately trying to preserve and reconstruct knowledge that they feared would be lost forever. The morning light illuminated stone surfaces that contained evidence of humanity's longest-running project, the systematic attempt to recover advanced knowledge that had been lost during the Great Catastrophe. The reconstruction had achieved remarkable success in restoring practical applications of ancient understanding, but it had never fully recovered the theoretical frameworks that would have enabled genuine advancement beyond pre-catastrophe achievements. The builders who had created these monuments weren't primitive people developing crude techniques through trial and error. They were sophisticated engineers working from incomplete instructions to reconstruct capabilities that had once enabled far greater achievements. Their success was measured not by how much they had innovated, but by how much they had managed to recover from the ruins of a more advanced civilization that cosmic catastrophe had nearly destroyed completely. The phone call that would end Dr. Sarah Mitchell's career came at 11:47 on a Tuesday night in March. The voice on the other end was calm, professional, and utterly terrifying in its quiet authority. Dr. Mitchell, we understand you've been researching certain archaeological anomalies. We'd like to schedule a meeting to discuss your findings. There was no identification, no agency affiliation, no explanation of how they had obtained her unlisted number. But Mitchell knew exactly what the call meant. Her investigation into suppressed evidence of pre-flood civilization had attracted attention from forces that possessed resources far beyond academic institutions. Mitchell had spent 18 months documenting the systematic suppression of archaeological discoveries that challenged conventional timelines. Her research had begun as an academic curiosity, but had evolved into something far more disturbing as she uncovered evidence of coordinated efforts to hide discoveries that suggested advanced, pre-catastrophe civilizations. The pattern of suppression extended across decades, involved multiple institutions, and operated with efficiency that suggested coordination by organizations with significant authority and resources. The suppression wasn't random or haphazard. Mitchell's analysis revealed systematic criteria that determined which discoveries were allowed public attention and which were quietly buried. Archaeological finds that supported conventional narratives about gradual human development received funding, publication, and institutional support. Discoveries that suggested advanced ancient capabilities faced obstacles that effectively prevented their integration into accepted historical frameworks. The suppression operated through multiple mechanisms that worked in coordination to control public understanding of human history. Academic institutions controlled research funding and publication opportunities. Government agencies classified discoveries under national security provisions. Museums determined which artifacts received public display and which remained in storage. Media organizations decided which archaeological stories received coverage and how they were presented to public audiences. The funding mechanisms provided the most effective suppression tool. Research grants were structured to discourage investigation into controversial topics. Graduate students who pursued dissertations challenging conventional timelines found themselves unable to secure academic positions. Established researchers who published findings suggesting advanced ancient capabilities faced career obstacles that effectively ended their ability to continue such work. Mitchell had documented dozens of cases where promising archaeological careers had been derailed after researchers reported discoveries that challenged accepted chronologies. The career destruction wasn't dramatic or obvious. It operated through subtle mechanisms that were difficult to prove but devastatingly effective. Funding applications were rejected without adequate explanation. Journal editors found technical reasons to reject papers regardless of their methodological rigor. Conference organizers excluded presentations that challenged conventional narratives. Dr. Virginia Steen McIntyre provided a perfect example of career destruction through institutional pressure. Her analysis of geological layers at Hueyatlaco in Mexico suggested human presence in the Americas far earlier than accepted timelines allowed. Despite rigorous methodology and independent confirmation of her dating techniques, her findings were rejected by institutions that refused to acknowledge evidence that contradicted established theories about New World colonization. Steen McIntyre faced systematic professional isolation that effectively ended her career in mainstream archaeology. Her funding was terminated, her research positions were eliminated, and her findings were excluded from academic discourse. The suppression wasn't based on methodological flaws or interpretive disagreements. It was motivated by institutional resistance to evidence that challenged fundamental assumptions about human chronology. Similar patterns appeared worldwide. Researchers who reported advanced capabilities in ancient cultures found themselves marginalized within academic institutions that claimed to value objective inquiry. The suppression crossed national boundaries and operated through international coordination between institutions that shared common interests in maintaining established historical narratives. Government involvement in archaeological suppression operated through classification policies that removed discoveries from public scrutiny under national security provisions. According to leaked documents that Mitchell had obtained through anonymous sources, archaeological findings were classified when they posed threats to social stability or challenged foundational historical narratives that supported established institutional authority. The classification process didn't require formal legal procedures or congressional oversight. Archaeological discoveries could be classified through administrative decisions that were not subject to public review or judicial challenge. Once classified, the discoveries became inaccessible to independent researchers and were stored in facilities that operated outside normal academic or museum systems. The Smithsonian Institution appeared to play a central role in archaeological suppression within the United States. According to whistleblower reports that Mitchell had documented, the institution's storage facilities contained thousands of artifacts that had been removed from public access when they challenged conventional timelines. The artifacts weren't displayed, weren't available for independent study, and weren't included in official catalogues that researchers could access. The suppressed artifacts allegedly included evidence of advanced metallurgy in pre-Columbian America, sophisticated astronomical instruments from ancient civilizations, and construction tools that demonstrated capabilities exceeding what conventional history attributed to ancient cultures. The artifacts were stored in facilities that required security clearances to access, effectively preventing independent verification of their significance. International coordination of suppression efforts operated through organizations that transcended national boundaries and academic institutions. The World Archaeological Congress, UNESCO heritage committees, and international museum associations all maintained policies that effectively prevented recognition of discoveries that challenged established chronologies. The coordination wasn't accidental or informal. Mitchell had obtained evidence of regular communications between institutions in different countries regarding problematic discoveries. When controversial artifacts surfaced in one nation, partner institutions in other countries were notified and coordinated their responses to prevent independent confirmation or alternative interpretations. The Vatican's role in archaeological suppression extended far beyond the protection of religious narratives. According to documents that Mitchell had obtained from anonymous sources within the church hierarchy, Vatican archives contained extensive collections of artifacts and texts that documented advanced pre-flood civilizations. The materials were stored in facilities that were inaccessible to independent researchers and were not included in official church scholarship. The Vatican's suppression efforts operated through its extensive network of educational institutions, research organizations, and cultural foundations. Archaeological discoveries that threatened religious or historical narratives could be suppressed through pressure applied by Vatican-affiliated organizations that possessed significant influence within academic and cultural institutions worldwide. Private collections provided another mechanism for removing problematic artifacts from public scrutiny. Wealthy collectors, often working in coordination with government agencies or institutional authorities, purchased artifacts that posed challenges to established narratives. Once in private hands, the artifacts became inaccessible to independent researchers while remaining under the control of organizations that could prevent their public recognition. The private collection system operated through networks that included museums, auction houses, and cultural foundations that shared common interests in controlling archaeological narratives. Problematic artifacts could be purchased, stored, and studied by authorized researchers while remaining hidden from public knowledge and independent investigation. Media coverage of archaeological discoveries was subject to coordination and control that ensured controversial findings received minimal attention or were presented in ways that minimized their significance. News organizations maintained relationships with government agencies and academic institutions that influenced how archaeological stories were reported to public audiences. The media control operated through multiple mechanisms that were difficult to detect, but highly effective. Stories that challenged conventional narratives could be delayed, edited, or suppressed entirely through pressure applied by advertisers, government sources, or institutional partners. When controversial discoveries were reported, they were often presented alongside expert commentary that dismissed their significance or questioned their authenticity. The suppression extended to documentary productions, educational programming, and popular science publications that shaped public understanding of archaeology and history. Production companies that created content challenging established narratives faced obstacles that included lost funding, distribution problems, and regulatory challenges that effectively prevented their work from reaching broad audiences. Digital suppression represented a new frontier in controlling archaeological information. Internet search algorithms could be adjusted to reduce the visibility of controversial content. Social media platforms could restrict the distribution of posts that challenged established narratives. Online databases could exclude or minimize references to problematic discoveries. The digital control operated through partnerships between technology companies and government agencies that enabled sophisticated manipulation of information flow. Content that challenged conventional historical narratives could be systematically reduced in visibility without obvious censorship that might attract public attention. Mitchell's investigation revealed that the modern suppression effort operated with resources and coordination that exceeded anything attempted in previous eras. The combination of academic control, government classification, media manipulation, and digital suppression created a comprehensive system that could prevent public awareness of archaeological discoveries, regardless of their significance or authenticity. The suppression wasn't motivated by scientific concerns about methodological rigor or interpretive accuracy. Internal documents that Mitchell had obtained revealed that suppression decisions were based on political considerations about maintaining historical narratives that supported established power structures. Archaeological evidence that suggested human civilization was older, more sophisticated, or more resilient than conventional narratives allowed was systematically excluded from public knowledge. The motivation for suppression became clear when Mitchell analyzed the implications of suppressed discoveries. Evidence of advanced pre-catastrophe civilizations suggested that current institutions might not represent the pinnacle of human achievement, but rather a recovery phase from catastrophic knowledge loss. If sophisticated civilizations had existed before recorded history, then modern authority structures might be more fragile and temporary than generally assumed. The suppression also protected economic interests that depended on controlling technological development and resource distribution. If ancient civilizations had possessed advanced capabilities, then alternative approaches to energy, construction, and social organization might be possible. The suppressed knowledge could enable technological developments that would challenge established economic systems and power relationships. As Mitchell prepared her final report, she realized that the suppression effort revealed as much about modern power structures as it did about ancient history. The coordination between government agencies, academic institutions, religious organizations, and media corporations demonstrated the existence of authority networks that operated beyond democratic oversight or public accountability. The phone call that night confirmed Mitchell's worst fears about the resources available to suppression authorities. The voice had possessed detailed knowledge of her research, her sources, and her intended publications. The implied threat was clear: continue the investigation and face consequences that would extend far beyond career destruction. But Mitchell also understood that the suppression effort was becoming increasingly difficult to maintain in the digital age. Information could be distributed through channels that were difficult to control completely. Independent researchers could collaborate across institutional boundaries. Alternative media platforms could reach audiences without traditional gatekeepers. The morning light streaming through Mitchell's office windows illuminated research files that contained evidence of humanity's most carefully guarded secret: the systematic suppression of archaeological discoveries that revealed the true scope of human achievement throughout history. The suppression had operated successfully for decades, but it faced new challenges from technologies and communication systems that made complete information control increasingly difficult. The battle between suppressed knowledge and institutional authority was entering a decisive phase. Either the evidence of advanced pre-catastrophe civilization would break through the suppression systems that had contained it for so long, or the control mechanisms would evolve to prevent any future revelation of humanity's forgotten past. The outcome would determine whether future generations would recover their true historical heritage or remain forever ignorant of the advanced civilizations that had once shared the same planet they now struggled to understand. The phone on Mitchell's desk remained silent, but the implicit threat lingered in the air like smoke from ancient fires that had once illuminated knowledge now hidden in darkness. The question was no longer what had been suppressed, but whether the suppression could be maintained indefinitely against the mounting pressure of evidence that demanded recognition, and the growing number of researchers who refused to accept the official silence that surrounded humanity's most profound archaeological discoveries.